Good day everyone. Welcome to my class again. This will be the part 2 of our video lesson. The part 1 was already uploaded in our Facebook group, the ENHS Senior High School Online Modality. Now, before we proceed to our lesson proper, let me remind everyone, to those who are not yet in the list of these respective sections that we have, please find ways to join in our Google Classroom because most of the activities will be uploaded here and some of the updates maybe, and I think some supplemental learning materials will also be uploaded here. And if you are the member, or if you have already joined in this Google Classroom, time to time you will be notified of the recent uploaded files or activities in our Google Classroom. Now, I think I have already sent the link of each of these Google Classroom that we have. All you need to do is to click on the link and accept my invitation so that you can join your respective section and you will be updated on the activities or recent uploads that we will be posting here in our Google Classroom. Having said that, class, let's go to our lesson for today. Our lesson for today, class, is about significant figures, scientific notation, and also the conversion factor. Actually, I have already discussed this one in our first video, but sad to say, I have to make a follow-up explanation on that because it is in very this will be the essentials, some of the essentials of the online video lessons that we have is the ability to upload many videos or supplemental videos for you to better understand the lesson or the specific competencies that we have in our curriculum guide. Now let's have our learning competency. The learning competency of this topic or this lesson. At the end of this lesson, you will be expected to solve measurement problems involving conversion of units, expression of measurement in a scientific notation. Now let's discuss about measurement. Hold on to this video, class, because at the end of this video I will be announcing, or I will be updating you on the activities that you will be I think submitted at the end of this week, I think. Now, measurement, class, the oldest way of measurement is what is cubit. Now, when we say cubit, class, this is the use of the part of our body, basically our hand or arm, I mean, for us to apply cubit, because this is the oldest way of measurement. So for you to know, for you to be aware of how to use cubit, basically when using cubit system, we utilize this way of measurement by means of considering our elbow, the tip of our elbow, from the tip of our elbow going to the tip of our middle finger, and approximately, according to the data that we have, this is approximately equivalent to 18 inches. This is the oldest way of measurement before. So when you have this one, the application of cubit, or if you use cubit, you are using approximation of the value of the measurement is 18 inches. So this is equivalent to 18 inches, but that depends on the length of your arm. That is why we came up with the so-called SI unit, or the International System Unit, to unify the measurement around the globe. Because if we don't have SI unit and still using cubit, maybe there will be a bias on our measurement, it's because we are not created by God with the same length, with the same height, with the same qualities in our bodies. That is why we the scientists utilize the unification of the measurement so that the 1 meter here in the Philippines, for example, is also equivalent to 1 meter in Japan, USA, and some of the countries around the globe. That is why from cubit, we apply SI unit to unify the actual or the uniform length of measurement. The 1 meter here is also equivalent to 1 meter length in USA. Now, in measurement class, we have fundamentals quantities in measurement. I have already mentioned this one in our video lesson number 1, but I have to emphasize again. Fundamental quantities are length, mass, time. SI unit for length is meter, mass, kilogram, time, second. Then the symbols are for length, small letter M, kilogram, for mass, and small letter S for time. And for British unit, for length is foot, and mass is for slag, and time for second. Another one is we have also common units in physics, and also in science. I think these units are also been applied. Now, for our common units, we have length, mass, time, electricity, temperature, luminous intensity, amount of substance. We know very well about length, mass, time. Electricity, it's amount of current flow in our particular appliances or some other industries that are using electricity. Now, we have also temperature, luminous intensity. When we say luminous intensity, we're dealing with the brightness of light and the amount of substance. Units for that, meter, kilogram, second. Electricity is for ampere. Temperature is Kelvin. That Kelvin is the SI unit for temperature. Fahrenheit and degree Celsius are not SI unit. Now, the SI unit for temperature is Kelvin. So you have to know that. Now, for luminous intensity, candela, and amount of substance is mole. The symbols are M, kilogram, kJ, S, big letter A for ampere, and big letter K for Kelvin. Absolute value, when we say Kelvin, it's an absolute value. And CD for candela and basically mole. Mole unit is commonly, I think, encountered in chemistry, in our chemistry class. But we will be, I think, encountering this unit as we go along in our discussions in physics, particularly when we reach the topic of thermodynamics. So we are using lots of mole units there. Okay, next one is we have also derived quantities or derived units. Derived units class is this will be the results or product or a combination of two or more quantities. This one, like for example, for force, or let's go for speed. The SI unit is meter per second, meter and second. That means speed is equals to meter per second. We know that meter is the unit or quantity unit for length, and S here is also the quantity unit for time. That means the derived units for speed is the combination of length and time. Length and time, or shall we say distance over time. And so as to the other quantities here, force, also the combination of mass and acceleration. And for acceleration, combination of length, as you can see here, meter per second squared, combination of length and time square. Okay, so those are the derived quantities that we will be encountering in physics. Actually, these are all basics, but I think although this topic or these concepts are basic, I think this is very important for us to learn physics as we go along. Now let's go to SI prefixes. We have also SI prefixes, and we will also be encountering this one as we go along in our, not only in physics, but most of the measurements that we have will also be applying SI prefixes. So we have exa, peta, tera, giga, mega, kilo. Now DC from alto is negative value. It means that the measurement is getting smaller and smaller. And from deca to exa, the measurement is getting bigger or larger and larger. For example, we have, why do we need to familiarize ourselves in SI prefixes? For example, no, we are given value. Like for example, we are given value of, shall we say, 10 microcoulomb. Now, this value is, we cannot basically compute or understand this value if we don't know our SI prefixes. Now, for micro, if we go back to our table here, for micro, that's the exponent for that is negative 6. This one, negative 6. That means 10 microcoulombs is equals to 10 times 10 raised to negative 6. Raised to negative 6. SI prefixes class is this one. Now, if you see this exponent expression, we call this one as SI prefixes, and some of the calculators that we have are also using x times 10 expression, that is also equals to exponent. But some calculators that we are using now is also using EXP for those students who are not totally oriented in SI prefixes. But for those students or for those calculators, or I think in physics and in engineering, most of the graphical calculators that we have are integrating SI prefixes in their system. So if you see this one, if you see x times 10 plus the exponent, we call that one as SI prefixes. Now, from 10 microcoulomb, this can be written as 10 times 10 raised to negative 6, since the value of micro here is 10 raised to negative 6. So if we express that, integrate that into a number, we will just add times 10 raised to that exponent. Okay? You can, I will be sending the copy of this one, don't worry. I will, the SI prefixes, I will send that to our Google Classroom. If you want to take note, some of the concepts that we will be presenting here, do the privilege of taking down that in your notebook. If you can able to do multitasking, writing while listening, much better. These are fundamentals. These are basics in physics. So you really have to be familiarized on these topics or concepts, because you will encounter a lot of this as we go along in our discussion. Now let's go to significant figures. Significant figures, this is very applicable, particularly when we are dealing with laboratory measurement. Having knowledge on significant figures can help you a lot, will help you a lot in trying to express the proper data for that specific measurement, particularly when doing laboratory experiments. When we say significant figures, This is basically a number of digits. Number of digits in a series of number. For example, if I have this number 1, 2, 3, 4, 5, 6, significant figures is the actual number of digits in the series of number. So this one, 1, 2, 3, 4, 5, 6, that is what we call significant figures, the number of digits in a series of number. So significant figure is necessary to elicit the precise reading report of data that have obtained from the experiment. Because some of our computations as we go along, and also not only in computation but in some laboratory procedures, we are obliged to express this measurement into a particular or specific number of digits only. So knowing significant figure is very important for you to write the proper number of digits on that measurement or on that data. Now let's go to the rules of significant figures. We have actually in our first video, because that video was just a introduction of what is really online video is. Now let's go to the details of that. Rules of significant figures. The first rule is all non-zero digits are significant. What do we mean by that? Okay, for example, let's go back first. Rules of significant figures. Number 1, all non-zero digits are significant. That means all non-zero. Think of the numbers that are not zero. So it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 11, etc. These are considered as a significant figure. So if I have, for example, for rule number 1, I will just write here, rule number 1. If I have this number, for example, 3.4444. Now, rule number 1, if we will apply rule number 1 here, and how many significant figures that we have in this series of number? According to rule number 1, all non-zero digits are considered significant. So all you need to do is to count this one. Since these are obviously non-zero number, so these are all considered as significant figure. That means we'll just have to count this one. 1, 2, 3, 4, 5. So how many significant figures that we have in this series of number? I will just simply answer 5 significant figures. So that's rule number 1. Let's go to our rule number 2. Rule number 2, all zeros between non-zero digits are significant. What do we mean by that? For rule number 2, all zeros between non-zero digits are significant. For example, I have this series of number 100503. How many significant figures that we have applying rule number 2? According to rule number 2, all zeros between non-zero digits are significant. That is why if we have to count the significant figure that we have here, all zeros here are counted. It's because in between the non-zero digit. So these are all considered as significant figure. So counting that one, 1, 2, 3, 4, 5, 6. How many significant figures that we have? In this example, we have 2, 4, 6. We have 6 significant figure. We'll just have write SF so that we can utilize, we can maximize our time. So that's for rule number 2. Let's go back to rule number 3. All zeros before the first non-zero digits are not significant. What do we mean by that? All zeros before the first non-zero digits are not significant. For example, for rule number 3. Rule number 3. For example, I have a series of number like this one. I will just have to think first. For example, this one, 0.0001. Okay. Now, how many significant figure that we have? Applying rule number 3, according to rule number 3. According to rule number 3, all zeros before the first non-zero digits are not significant. That is why zeros before non-zero digit is or are not significant. So these zeros here cannot be counted as significant. It's because of the rule number 3. So how many significant figures that we have in this series of number? Only one significant figure only. So that's for rule number 3. Let's go to rule number 4. All zeros to the right of the last non-zero digits are significant. All zeros to the right of the last non-zero digits are significant. Okay. How do we explain that? For rule number 4, we'll just have to write here. Rule number 4. All zeros to the right of the last non-zero digits are significant. Example, 100, or we can say 5.500. 5.500. How many significant figures that we have? According to rule number 5, zeros here can be counted. It's because to the right of the non-zero digits. So we can count that one. This one is how many significant figure? 1, 2, 3, 4. So we have four significant figures. And these are the explanation or closer look on the significant figures. For rule number 1, all non-zero digits are significant, and this one. Rule number 2, all zeros between non-zero digits can also be considered as significant, this one. And rule number 3, zeros before non-zero digit are not significant. And rule number 4, zeros after or to the right of non-zero digit are significant. You can copy that. You can post this video and copy this example, because these rules are not included in our module. That is why you are lucky, because you took you decided to have your online class. You can post the video and copy these rules so that you can easily study your notes when you will be answering the activities that we have. But for now, let's focus on this lesson. Those are rules of significant figures. Be careful of this one. Non-zero digit is always considered a significant figure. I think this is very clear. A note for us to easily understand the rules of significant. The position of the zero, or whether it is counted as significant or not. Zeros can be significant depending on the position of that number or of the zero. So it can be to the left, to the right, in between. So it's up to the rules of significant figures to decide whether we count that zero or not. So just remember this note. That would be all. If you have some clarifications regarding the topics today, you can chat directly to our group chat, and I will be happy to hear from you after this video lesson. Thank you so much for your time, and try to save, try to download this video lesson that we have, so that you have you can study it anytime. And if you have also, you can copy this one as well. You can copy this one in your notebook, because this will help you a lot when you will be in college. Believe me. That is why I made this video. Although this is totally not in the module, but we try to present it for the sake of your knowledge. Thank you so much for your time. See you in the next video.